We're in Module 13, and we started it the other day, and we were graphing, and we were just talking about two formulas, the distance and the midpoint. Well, today we're actually going to get to graph some lines. So in Module 13b, we're going to talk about graphing linear equations. So let's go to our notes. Okay, before we even start graphing an equation, we've got to go through some basic vocabulary. The words of graphing have not changed since Algebra 1. So you're going to hear the same words you heard back then. So let's just go through this and make sure we're all on the same page. First of all, the thing that you graph on has a name. It's called the Cartesian coordinate system. And it was developed by a French mathematician, René Descartes. So you could see Descartes is his last name, and we use his name when we say the Cartesian coordinate system. And what you know that is as the x and y axis. He is the first mathematician that visually took what you were solving on paper and making a picture of it. And what René said is if you take two number lines and draw them perpendicular to each other, you will have the Cartesian coordinate system. And we know the number line that goes across left to right is called the x-axis, and the number line that goes up and down is called the y-axis. We also know where those two number lines meet in the center is called the origin. We then know that when you take those two number lines and you intersect them, they make four boxes or four quadrants. And basically our job on this system is to plot points. And a point is called an ordered pair because it has two values. It has an x value and y value. So if you look here at the PowerPoint notes, you could see there's your Cartesian coordinate system. You drew the horizontal number line, the x-axis, the vertical number line, the y-axis. The point where they meet is called the origin. And then you have the four quadrants. And the quadrants just help us locate. So if I said to everybody look in quadrant 2, everybody would look in the same spot. Our goal is to draw pictures of equations. So what we're going to have to do on this system is plot points and then connect the dots like we would do as a little child. Okay? So what we're going to be doing is drawing equations. Now, the first thing we need to start with is which equation are we going to draw first? When we started out college algebra, we're talking about linear equations. And linear is a Latin word, and in that word is the word line. And that's what linear equations draw to be. They draw pictures of lines. So what we're going to do today is we're going to be drawing lines. Now, I want everybody to come over here. Let's look at me for a minute. Okay, if our goal is to draw lines, then what you need to understand is you can only form three types of lines. If you hold your hands out this way, from left to right, you're making a line. It is a horizontal line. If you put your hands up and down like this, you are making a vertical line. And if you hold your hands slanted and slanted, you're making a diagonal line. So in this module, we're going to be graphing linear equations. Linear equations make lines. There are only three types of lines I could ask you to draw: horizontal, vertical, diagonal. Okay, let's go back to the notes. So what first thing you're going to need to do is memorize some facts. And it's very simple. The first fact is you always know what you're going to draw by looking at the equation. The equation is going to tell you whether the line is only going to touch the x-axis, the y-axis, or both axes. So if you look here at the notes, you will know you're drawing a horizontal line because it just has the letter y in it. So you've got to memorize the letter y makes a horizontal line. A vertical line will only have in the equation the letter x. So if you see in your equation just the letter x, you're going to draw a vertical line. And a diagonal line will always touch both axes. It has both variables. So if you look, a diagonal line equation will have a y and an x. So that's the most important thing. Now, why is that important? Because look here. I have up here 7 equations. What I want you to notice is you should know what you're drawing by just looking at the variables. So if you look here, which equations just have the letter y in them? Well, that's equation A. A has a y in it. That means that's going to be a picture of a horizontal line. which equations just have a letter x? Well, that's equation B and equation E. They just have a letter x in them. So those would be vertical lines. Equations C, D, and G have an x and a y. It doesn't matter if they're on the left side or right side. Equations C, D, and G have the letter x and the letter y. That means those would be pictures of diagonal lines. Now, the only equation I skipped was F, because equation F doesn't just have an x, it has an f of x. And we already discussed that. That is function notation. And what you're to do with function notation is every time you see it, you're to cross it out. And what variable are you supposed to put? That's right, you're supposed to put the letter y. So I would rewrite that equation not as f of x equals -1, but y equals -1. And if it just has the letter y, it's going to be what type of line? That's right, it's going to be horizontal. So it's very important that you understand, before you ever go to the graph paper, you should know what you're drawing by looking at the equation. The letter in it, the variable in it, will tell you what type of line to draw. Now, there are 3 ways we can graph a diagonal line. And this is important. We're going to build from how you learned it first to the quicker or more efficient method. Back in elementary school, you should have learned to set up a t-table. And in that t-table, you'll have x values and y values. And that's what you'll use to graph a line. So let me show you an example. This is the first example we want to graph. The equation up on the top is 5x minus 2y equals 10. But then you see a t-table given. And a t-table gets its name because it has a letter T. And you're given some x values and some y values. So what I'm about to show you is how you use a t-table to graph an equation. Let's go to the whiteboard. Okay, so first of all, what I want you to notice is, oh, I didn't get to the whiteboard. I'm sorry. Okay, guys, here I am. So what I want you to notice is I gave you this equation, 5x minus 2y equals 10. Before you ever touch the paper, you should make a decision. Is it horizontal, vertical, or diagonal? It has the letter x, it has the letter y. That means this picture is going to touch both the x and the y axis. It's got to be a diagonal line. So I'm going to write myself that note. It's going to be diagonal. Now, the easiest way that you all learned to graph a diagonal line is to plot points. But to plot points, you need an x value and a y value. Well, in a t-table, I start you off by giving you some of the values. So we're going to have to find the missing part. So if you look here, I'm giving you 5. 5 represents y. Well, if you know y is 5, how would you get the number for x? What would you do? Very good. You would take this number and substitute it in the equation. So now I want you to make a connection. Do you understand why we had to learn to solve equations first? Because you got to know how to work an equation before you can graph it, draw a picture. So I'm going to write this equation. 5x minus 2, but instead of leaving y, I'm going to replace it with 5, equals 10. Now I'm going to solve it. So I'll do my multiplying. 5x minus 10 equals 10. It's a simple linear equation to solve. I'll add 10. 5x equals 20. I'll divide by 5, and I'll get x is 4. And I'll put that in my t-table. What you've done is you've now made an ordered pair. You have an x value and a y value. Now you can go to your graph paper and plot that. So I'll go to x is 4. Let me label my axes here for you. So I'll go to x is 4, and I'll go to y is 5, and there's my first point to plot. But I can't draw a line yet because plotting one point doesn't guarantee which line it is. This line could be horizontal, this line could be vertical, this line could be diagonal. So I need some more information. So I go to my t-table. Here's my next piece of information. They give me a 1, but 1 is in the column for x. So I'm going to substitute in for 1 where the x is. So I'm using the same equation because that's what I want to draw a picture of, that equation. So to write the same equation, 5x minus 2y equals 10. But now I'm going to substitute x as 1. So I'm going to write 5 times 1 minus 2y equals 10. I'm going to multiply 5 minus 2y equals 10. And now I'm going to solve. I'm going to subtract 5. Negative 2y equals 10 minus 5 is 5. I'm going to divide by negative 2. And now you have a choice. You could either write that as an improper fraction, negative 5 halves, or you could divide it out and make that decimal that terminates, that stops. Negative 5 divided by 2 is negative 2 and 5/10. And as you all know, to graph, it's much easier to work with decimals to find out what they are in the number line versus the fractions. So now I can go plot that point. I can go to x is 1, and I can go to y is negative 2.5, which would be somewhere in between negative 2 and negative 3. Now, I have 2 points. Can I connect them? Sure I can. And if I connect them, I would make a diagonal line. And that's the minimal number of points you need, is just 2. But because our t-table gives us another value, we have to continue. So on our t-table, I have another number. It's negative 5. It's going to replace y. So we're going to do the process over. We're going to write 5x minus 2. X now is negative 5 equals 10. We'll multiply, so we'll get 5x, a negative times a negative is a positive 10, equals 10. We'll subtract our 10. We'll get 5x equals 10 minus 10 is 0. We'll divide by 5. And nothing divided among 5 people. If I have nothing and I divide it among 5 of you, you all get nothing. So that's a 0. So now I'm going to go plot that third ordered pair, that third point. 0, negative 5 means I'm at the origin. I don't move left or right because my x value is 0. My y value says move down 5. And now I have enough information for sure, and I should be using a straight edge, and I apologize. I don't have a straight edge today. And that would connect and make a nice diagonal line. So René Descartes, this French mathematician, wanted you to make a connection. Every equation on paper makes a picture. Because this is a linear equation, x to the first, y to the first, linear equations make pictures of lines. Because this equation has both an x and a y, it will make a diagonal line. And everybody look, this line touches the x-axis. This line touches the y-axis. That's why a diagonal line has both variables in its equation. All right, let's go back to our notes. All right, so now we understand that you can use a t-table to graph a diagonal line. But you know what? That took a lot of work. And I'm not all against work, but you know, mathematicians are about doing things quick and efficient. So let's keep going. The easiest method, the quickest method to graph a diagonal line is not to do a t-table. The easiest method is to use the numbers you see in the equation. And what you do is very simple. To graph a diagonal line, your equation has to have the letter y isolated. And that is called slope-intercept form. So you will hear in the directions, graph the line in slope-intercept form. That word, slope-intercept form, means to you to get the letter y isolated. When you get the y all by itself on the left side, on the right side you will see the letter x. And there will be a number in front of x that's connected by multiplication. That's the m. There will be a number behind x that is connected by either add or subtract, and that's the b. So think of it. M means the numbers multiplied to x. B means the numbers behind x. And those are the two numbers you will use to go to the graph paper. And you won't have to do any work. So to graph a diagonal line, you need to be in slope-intercept form. So let's go back to the whiteboard and let's go over this. So let's get the whiteboard to come up. Here we go. All right. So let's look at my next equation. The next equation is y equals 2x minus 1. You know that that is going to be a picture of a diagonal line because it has an x and a y. That's the first thing. Now, instead of us making a t-table and picking numbers to get other values, that's too much work. All you need to do to graph a diagonal line is get it in what we call slope-intercept form. Say that, slope-intercept form. That's a fancy word to say get y isolated. So everybody look up here. Look at my equation. Is my y isolated? It sure is. Here's the equal sign. Y is by itself. That is what they mean by slope-intercept form. Now, you'll see it written in the book, y equals mx plus b. Slope-intercept form means the y is by itself on the left, the x is on the right. When the x is on the right, there's going to be a number in front connected by multiplication, m for multiplication, and there's going to be a number connected to x that's behind it by addition and subtraction. So everybody look at my equation. I know it's a diagonal line. It has an x and a y. Is it in slope-intercept form? Sure it is. Y is by itself. Well, then you should see the number that's connected by multiplication to x. You should see the number that is behind x. What number is connected by multiplication to x? The 2. What number is behind x? The -1. And those are the two numbers you will use to draw the picture. Now, you just can't do whatever you want with those numbers. You got to know what those numbers mean. These letters M and B stand for math words. You got to know vocabulary. So, the first thing is, what does the letter M stand for? The letter M stands for the word slope. You're going to say, huh? M stands for the word slope? Why did they use the letter M? Well, remember, René Descartes was a French mathematician. And the French word for slope is mentir. And mentir means movement. Slope is the movement of the line. It's going to explain to you how to move. Well, sweeties, you can't move yet. You don't even have a starting position. So the other number that's behind the x stands for word. The B stands for the word y-intercept. Now, you're going to say, why do they use the letter B for the word y-intercept? Why don't they use the letter y? Well, you already have a y in the equation. You can't have two. So, these are the two numbers you're going to need. M and B means multiplied behind. But M and B also mean begin and move. You always draw a diagonal line with beginning with the y-intercept. So you begin with B and you use M to move. You need a starting point to move. All right, so now we got to go over vocabulary. What does the word y-intercept mean? Well, think about football. If a football player intercepts a football, that means they physically get it from the other team. They're touching it, they're holding it. A y-intercept means you're touching. You are physically touching the y-axis. That is why it's called the y-intercept. So the y-intercept is a point on the y-axis. So everybody look here. What is your b value? It's -1. That is your y-intercept. You will go to the y-axis to -1 and put a point. Okay? Here's the y-axis. Here's -1. Now that you're done using the begin, the y-intercept, now we're ready to move. Movement is slope. The problem is, what's your slope number? It's a 2. Well, what does that mean to the graph paper? From here, do I go up 2, down 2, right 2, left 2? Well, the first problem is to move on this system, you have two options. Do you move up or down? That's one option. Do you move right or left? That's a second option. So what you're going to learn is when we talk about slope, it should always be written as a fraction. So how do you take any number, whole number, 2, and write it as a fraction? You write it as 2 over 1. Everybody agree with that? 2 divided by 1 is 2. Now, when you change it to a fraction, this is what you're going to memorize. Slope is rise over run. What is slope? Rise over run. Because if you remember that, then you'll understand what direction each of these numbers tell you to move. If you rise, what does that mean? You get up. So the numerator is always going to tell you whether you go up, or the opposite of up is down. When you run, like I'm doing here, I'm running, I'm not going up or down, I'm going right and left. So what you got to know is this. The number that's connected by multiplication to x, which is 2, needs to be written as a fraction because it is slope. And slope's going to tell us how to move. And once you write it as a fraction, the numerator tells you to go up or down. The denominator tells you to go right or left. So knowing that, let's go to our picture. I am here. I'm beginning at -1, my y-intercept. My slope says to rise 2. Because 2 is positive, I count up 1, 2. But I don't stop yet. My denominator says I'm supposed to run 1. Because 1 is positive, I'm going to run 1 to the right. And that's where the next point would go. I went up 2 to the right 1. Now, can you make a line? Sure you can. When you connect it, what type of line? Diagonal. The great thing about this is you can do it as many times as you want. Up 2 to the right 1. Up 2 to the right 1. Suppose you're here and you want to extend the line left. Well, then you would just go backwards. Instead of going up and to the right, you're going to go down 2 to the left 1. Down 2 to the left 1. And if you connect all those lovely points, you will make the diagonal line. Now, I know you're thinking that's way more work, but it really isn't. Because look, all you had to do was look at the equation. The number connected by multiplying is the m. The number behind is the b. All you got to memorize is which number to use first. I just told you, begin and move, baby. You begin with b, you use m to move. You always begin on which axis? The y-axis, because this letter b stands for the word y-intercept. So we begin on the y-axis at -1. M stands for slope. Slope is movement. Because slope is movement, we have to write it as a fraction. And if you remember rise over run, you can't screw that up. Okay? I think we have another example. Let me get my clicker here. Sure we do. Let's do the next one. So let me erase this. Okay? Here's my equation. -x minus 3y equals -6. So what I expect you all to do is look at that equation. It has an x, it has a y. It's got to be what type of line? Diagonal. Every diagonal line is going to touch the x and y axis. Look here. This touched the y axis, it touched the x axis. Every diagonal line will touch both axes. That's why it has both letters. The problem with this equation is it in slope-intercept form? What does that word mean again, slope-intercept form? It means who's isolated? The y. Here's the equals. Is the letter y on the left side by itself? No. So now you got to do some work. But guys and gals, have we not just worked through all these modules on how to move terms across an equals? That's the whole goal of equations. So you know how to get y by itself. You're going to add x. Watch your sign. That's -3y equals. You can't add a -6 to an x, so we're going to write it in the correct order. We're going to write x first and then the constant -6. Y is still not by itself This is connected by multiplication, so we're going to do division. If we divide this term by negative 3, we divide every term by negative 3. Remember, keep in balance. Cancels. Y equals. Everybody, what's the number in front of the x? It's a 1. Can you divide 1 by negative 3? No, you make a fraction. That's negative 1/3. And you put the x to the side in graphing. Remember, the negative's got to float to the top. Over here, you have negative 6 divided by negative 3, which is positive 2. This right here is still a diagonal line equation. It still has an x, it still has a y. But now it's in the correct form to draw the picture. What form is this? Slope-intercept form. All you need are the two numbers. So if you remember m and b, you got this made. M means multiplied. What number is connected to x by multiply? Negative 1/3. B means behind. What number is behind x? Positive 2. Now that you know the two numbers, you got to know what it means to go to the graph paper. So let me erase this line. All right. If you remember the phrase, begin and move, you can never screw this up. You begin with the B number. It's 2. But which 2 do you go to? Do you go to 2 on the x-axis or the y-axis? Well, this is vocabulary. The letter B stands for what word? Y-intercept. What word? Y-intercept. So you're always going to begin on the y-axis. So we'll go to the y-axis to 2. The letter M stands for what word? That stands for slope. Slope tells you how to move. Slope has got to be written as a fraction. Well, that's done for us. We have a fraction, negative 1/3. So you'll see me write rise over run. So this says we're going to rise negative 1. Well, you can't rise negative 1. You can't go up negative 1. That means you're going to go down 1. So if the numerator is negative for slope, you're going to go down. Your denominator is still positive. Running is right or left. If it's positive, you're going to run to the right. So that slope's telling me to go down 1, to the right 1, 2, 3. And that's where I put my next point. And you can do it as many times as you want. Down 1, 1, 2, 3 to the right. If you want to reverse it, here I am at 2. I would go up 1, to the left 1, 2, 3. And then I can connect my points with a straight edge and make a diagonal line. It's real simple. It just takes practice. And it takes more understanding what the numbers mean. Okay, we got one more. Okay, so in our notes, here's our next one. X over 2 plus y over 3 equals 1. If y'all look, it's an equation. It has an x and a y, so it makes a picture of a diagonal line. It's still a linear equation. X to the first, y to the first. To draw a picture of a diagonal line, what form do we want that equation in? Slope-intercept. What does that mean? That means we want y by itself. Well, sweethearts, before I ever get y by itself, what do I not like about this equation we've talked about all semester? That's right, I don't like the fractions. We learned a long time ago, if you're dealing with equations and they have fractions, get rid of them. To get rid of a fraction, what operation do we do? Very good. We do multiplication because this is divide, this is divide. To get rid of it, you multiply. But you can't multiply by different numbers. You got to multiply by the same number. What was that called? Very good, the LCD. So what's the least common denominator of 2 and 3? It's 6. So we're going to multiply by 6. We're going to multiply by 6. We got to balance it. We got to multiply the right side by 6. So 6 divided by 2 makes 3, and 3 times x is 3x. 6 divided by 3 is 2, and 2 times y is 2y. And there's a plus sign between them. equals. There's no division here, so 1 times 6 is 6. Now, do you agree with me? Now that you got rid of the fractions, you can now move the terms to get y by itself. I'll subtract 3x. 2y equals. I'm going to write the x first in the correct descending order, then the plus 6. But I'm not done. Is y by itself? So I'm going to divide everybody by 2 because you got to keep balance. And I get y equals -3 doesn't divide by 2 nicely, so I'm going to leave it a fraction. I'm going to put the x to the side. 6 divided by 2 is +3. There's your equation. Does it still have an x and y? Sure it does. So it's still a diagonal line. But now it's ready to graph because it's in slope-intercept form. You see the number connected to the x by multiplication. You see the number behind the x. So let's write down those two numbers. My m is here, -3/2. My b behind is +3. Once I have those two numbers, all I got to do is put them on the graph paper. How do you know which one to use first? I gave you a phrase. Begin, move. Begin with b. b is 3. Well, there's a 3 on the x-axis. There's a 3 on the y-axis. Do you just go eeny, meeny, miny, mo? No, you don't. You listen to the vocabulary. The letter B stands for what word? It stands for y-intercept. Say it, y-intercept. That means this B begins on the y-axis. So there I am at 3 on the y-axis. M stands for what word? It stands for slope. Slope tells you how to move. So we're going to write our phrase, rise, run. If you remember slope is rise of a run, you got it. So we're going to rise -3. Well, here I am, where I'm beginning. When I say I'm going to rise -3, am I going to go up 3 or down 3? Very good. That means down 3. So here I am. I'm going to count 1, 2, 3. But I'm not done. I got to run 2. The 2 is positive, which means I always go to the right, because that's where the positive numbers are. 1, 2. And that'll be the second point. And if I connect them, sure enough, it makes a diagonal line. So what I showed you is the fact that to graph a diagonal line, you could do a t-table. But that's way more work than just getting the equation in slope-intercept form, getting the slope and y-intercept, and going to the graph. Now, there's still another way. There are 3 ways to graph a diagonal line. Let's go back to the notes. So if we go back to our notes, we're still not done. Okay. The next way we could graph a line is called using the intercepts. Now, we just saw every time you graph a diagonal line, it touches the x-axis and y-axis. We just heard the word y-intercept. Y-intercept means where you touch the y-axis. X-intercept means where you touch the x-axis. So, we have 4 pictures here, 4 graphs, A, B, C, and D. Each one of them has a line on it. What type of line is A? Good, it's diagonal. What type of line is B? Good, it's horizontal. What type of line is C? That's right, it's diagonal. What type of line is D? That is vertical. And if you look closely, some of those lines touch both axes. Some of them just touch one axis. Where they touch the axis are called the intercepts. So what we're going to do is we're going to look at each picture and we're going to talk about its intercepts. So the easiest way for me to do this is we're going to go back to the whiteboard. All right. Let me get the whiteboard. All right. So if you look at the first picture of that diagonal line, they have a point plotted on the y-axis at 5, and they have a point plotted on the x-axis at -3. And that's making a diagonal line. These 2 points have names. If this point touches the x-axis, it's called the x-intercept. If this point touches the y-axis, it's called the y-intercept. So on your chart, on your notes, we're going to fill it in. I want to know where this x-intercept is located. If you just write -3, I have to mark you wrong. It's a point. Every point has an x value and a y value and goes in parentheses. So everybody look at this point. What is this point's x value? Well, its x value is -3. It's on the x-axis. What is this point's y value? Well, to plot this point, you didn't have to go up or down. Well, if you don't go up or down, that means your y value is 0. Okay? If you remember to plot a point, you're technically starting from the origin and you're saying I went left 3 and I didn't go up or down. All right, now if you look at that line, we have an x-intercept. I mean a y-intercept. That's where we're touching the y-axis. So again, if you just say the y-intercept is 5, I got to mark you wrong. You got to write it as a point. A point always has 2 numbers. So if I ask you what is the x value of this point, it is not 5. X is 0. To get to this point, you didn't move right or left. You stayed put. To get to this point, you moved up 5. That 5 is its y value. So first of all, everybody look closely. If you name an x-intercept, the number goes in the spot for x. If you name a y-intercept, the number went in the spot for y. Okay? Everybody's good? All right, let's look at the next graph. All right? The next graph, you have a horizontal line, and it is touching the the y-axis at 4. So what I want you to notice is, does that horizontal line ever touch this x-axis? No, they're parallel. If you don't touch the x-axis, then you do not have an x-intercept. Now, you don't say no solution. We didn't solve an equation. I just asked you a question. Does this line have an x-intercept? You would say, no, ma'am. Well, the way you write that is you say no x-intercept. And a horizontal line is never going to touch the x-axis. But does a horizontal line touch the y-axis? Sure, it touches right here. What number are we at? 4. So when I write that y-intercept, it touches the y-axis at what number? 4. So the 4 is going in for the spot for y. What's the x value? 0. To get to this point, you didn't go to the right, you didn't go to the left, you just went straight up. That's why the x value is 0. Everybody's okay? So not every line touches both axes. Okay, if we look at the third picture on our notes. Erase this. Our third picture, there's only one point plotted. It's plotted at the origin. And there's a line drawn through it. It's a diagonal line. So again, if it's a diagonal line, it always touches both axes. Every diagonal line has an x-intercept and a y-intercept. So everybody look. Where does this point touch the x-axis? Well, here's the x-axis. It's touching it at 0. You all know that's in the middle of the graph. That's the origin. You name the origin by saying 0, 0. Now, if you look, this point is also on the y-axis. Here's the y-axis. I'm following it. There it is. So the y-intercept is also at 0. And we write that as 0, 0. That is the only time in all of graphing the x-intercept and the y-intercept will be at the same place, is when you draw a diagonal line right through the origin. So remember, diagonal lines have both x-intercepts and y-intercepts. X-intercepts and y-intercepts. It just so happened this one had the same. All right, we got one more line to look at. Now, the last line is vertical. It's going up and down. Well, again, does a vertical line touch both axes? Well, does it touch the x-axis? Sure it does. It's touching right there. Here's the x-axis, and sure enough, it touches it. It's touching it at 3. So a vertical line has an x-intercept. Because it touches the x-axis, the number 3 goes in the spot for x. And the y value is 0. And that makes sense. To plot this point, you went right 3, and you didn't go anywhere else. You didn't go up or down. Now, does a vertical line have a y-intercept? Does this line touch the y-axis? No way. They're side by side. They're parallel. A vertical line will never touch the y-axis. So what are we going to say about its y-intercept? There is none. No y-intercept. So what I want you to get out of this right now is to understand what the definition of an intercept is and why some lines have both intercepts and some only have one. Now, our goal is to graph an equation. So how is this going to help us graph an equation? Well, think about it. I'm about to give you an equation with x's and y's, a diagonal line. And I'm going to ask you to graph it not by doing a t-table, not by putting it in slope-intercept form. I'm going to say graph the diagonal line, finding the intercepts. So we got to come up with a way to look at an equation, something with an equals, and figure out how to find these numbers. Well, sweeties, this is what mathematicians did. They noticed a pattern. If you look very closely, all the x-intercepts have something in common. They all have for y 0. Do you all see that? Think about it. If you're sitting on the x-axis, no matter where you are on the x-axis, that point never goes up, never goes down. That means its y value is going to be 0. That's going to be our rule. To find an x-intercept, you're going to substitute for y 0. And vice versa. If you look at all the y-intercepts, look what they all have in common. They all have zeros. Zeros in the place of x. So think about that. If you're sitting on the y-axis, you didn't move left or right, you just went up or down. So if you don't go left or right, your x value is going to be 0. So now, when you go to the next slide, you will see the rule. To find the intercepts, if I want the x-intercept, you replace y with 0. If I want the y-intercept, you replace x with 0. So let's look at our last diagonal line to graph. In our notes, this is the last diagonal line. It says 6x minus 9y minus 18 equals 0. How do you know it's a diagonal line? It has an x and a y. Okay? So I said in the beginning, there's 3 ways to graph a diagonal line. I could give you a t-table and give you some numbers to substitute in. We don't want to do that. That's too much work. I could ask you to get y by itself, put it in slope-intercept form. Okay? But on this set of directions, it says, graph the diagonal line, finding its intercepts. I want to know where it touches the x-axis, and I want to know where it touches the y-axis. So the rule is, if I want to find an x-intercept, I want to know what x is. I want to solve for x. Well, if I want to solve for x, I got to get rid of this other variable, y. And the only number that's going to get rid of it is using 0. So to find an x-intercept, you let y be 0. It's a simple substitution. So you write 6x minus 9. I'm going to replace y with 0 minus 18 equals 0. And we're going to solve it. Now, guys, what's 9 times 0? 0. So you agree I can just cross that out? It's gone. So my equation is 6x minus 18 equals 0. And you could solve that. You would add 18. You would get 6x equals 18. You would divide by 6 and get x equals 3. Now, because it's an intercept, it has to be written as a point. So you just found out, what is x? 3. What was y? Well, you replaced y with 0. Now, if that truly is the x-intercept, 3, 0, When you go to the graph paper, it should sit on the x-axis. Let's see. Let's erase this. Let's go to the x-axis. So if I go to 3, 0, I'm supposed to move to the right 3. I'm not going up or down. Sure enough, there it is. I am on the x-axis. It is very easy to understand this. To find the x-intercept, you want to keep the letter x. You want to get rid of y. The only number you can substitute in to get rid of y is 0. Now we're going to do the reverse. It says not to only find the x-intercept, it says to find the y-intercept. So to find the y-intercept, we're going to do just the reverse. I want to keep y, so to get rid of x, I let x be 0. So same equation, I'm now asking to find the y-intercept. So if I want to find y, I keep y. I want to get rid of x by using 0. So I'll write 6 times 0 minus 9x minus 18 equals 0. Simple substitution. What's 6 times 0? That's nothing. Cross it out. It's gone. That's what your goal was, to get rid of that. So now you have negative 9x, negative 9y minus 18 equals 0. I add 18. Negative 9y equals 18. I divide by negative 9. And 18 divided by negative 9 is negative 2. But it's got to be written as a point. An x-intercept and a y-intercept are points. You have to write them as points. So when I come over here to write my point, this is the y value, negative 2. What did you let the x value be? You let it be 0. If I plot that point, it better be on the y-axis. So here I go. I'm at the origin. To plot a point, you always start at the origin. 0 means I don't move right or left. Negative 2 means I just move down 2. Sure enough, that's on the y-axis. And if I connect those 2 points, do they make the diagonal line I said? They sure do. So to graph a diagonal line, there are 3 different methods. T-tables, slope-intercept form, intercepts. You have to read the directions to figure out which way they want the line drawn. Now, I saved the easy part for last. If you look at your notes, the last thing we have to graph are the other 2 lines. I did diagonals first because there's 3 ways to graph them. But the other 2 lines, horizontal and vertical, are very simple. So let's finish it up. Let me erase this. All right. So if you look at your notes, the next equation we want to graph is y equals 2. Okay, guys, do you see an x and a y? No. It is not a diagonal line. So we don't got to worry about doing a t-table. We don't got to worry about slope-intercept form. We don't got to worry about anything. That has just the letter y. We started off this lesson saying the variable tells you what you're going to draw. This says y equals 2. The equation's telling you where to go. It's saying, hey, go to the y-axis, to the number 2. Well, I can do that. Here's the y-axis. Here's the number 2. That's 1 point. To draw a line, how many points do you need? You need 2. So you're going to say, well, where does the second point come from? This says, draw me, plot points wherever a y value is 2. Is this the only point that has a y value 2? Heck no. Do you agree if I plot this point? The x value is 3, but what's the y value? It's 2. And do you agree if I plot this point? Even though the x value is negative 4, the y value is 2. When you say y equals 2, you're saying plot every point that has a y value of 2. Well, that's every point to the right, and that's every point to the left. And if you connect all those points, what type of line do you see? Horizontal. So that's where we started today's lesson. I told you, if you see the letter y, it will always be a horizontal line. This letter tells you what axis you touch. When you go to draw that line, it can only touch the y-axis. That's it. Pretty simple, right? All right, we got one more. 3x minus 15 equals 0. All right, look at the equation very carefully. What variable is in that equation? The only variable in this equation is the letter x. So can it be a diagonal line? No. If the letter y means horizontal line, what do you think the letter x means? Very good. This is going to be a vertical line. Now, it's not ready to draw yet because it's not telling you where to go. See how this was y equals 2? It told you go to the y-axis to 2. We need to get this one ready to tell us where to go. So what are you going to do? That's right, you're going to use your skills and get x by itself. So we're going to add 15. 3x equals 15. We're going to divide by 3 and get x equals 5. That I understand. That says go to the x-axis to the number 5. So I will do that. I will go to the x-axis to the number 5. But that's only 1 point. How many points do you need to draw a line? You need 2. Where does the second point come from? You have no other information here. It just says x equals 5. What other point has an x value of 5? Any point above? This would be 5, 1, 5, 2, 5, 3, 5, 4. Those all have x values of 5. And the points below, 5, negative 1, 5, negative 2, 5, negative 3. So any point going above or below what you plotted have x values of 5. Well, if you connect the dots, the points, you make a vertical line. The variable tells you what you're going to touch. This says this line is only going to touch the x-axis at 5. So what you got to memorize is really simple. There are 3 types of lines: horizontal, vertical, diagonal. Each line has its own variable, its own letter. Horizontals are y equals, verticals are x equals, and diagonals are y equals mx plus b. And the reason why we say diagonals are y equals mx plus b, because we just saw you want to get the y by itself to graph a diagonal line. So you will hear me, if you ever came by Bipsy, you'll hear me sing horizontal, vertical, diagonal. Y equals x equals y equals mx plus b. That's how we memorize it. So try it with me. Horizontal, vertical, diagonal. Y equals x equals y equals mx plus b. So today's lesson was all about making that connection. Every equation that was linear that you solved modules ago are pictures of lines. There's only 3 lines you can draw: horizontal, vertical, and diagonal. The variable inside the equation tells you what you're going to draw. If you just have the letter y, the line can only touch the y-axis, horizontal. If you just have the letter x, the line can only touch the x-axis, vertical. If the equation had both an x and a y, it would touch both axes, diagonal. Okay, I hope you learned something. Have a great day.